Hello. Today we're going to talk about 1-6, absolute value and distance. The big idea is the absolute value of a number and the distance between two numbers on a number line are closely related. Absolute value and distance. From the right vertical number line drawn above, you can see that the geometric interpretation of absolute value. Absolute value, the absolute value of a number is the distance from zero, okay? Distance is always positive. So that's what's going to happen when you get an absolute value symbol. And you should have seen absolute value before. Remember, it's these two little lines that go vertically up and down. That symbol or absolute value. It says because the absolute value of a number is a distance, it is never negative. Using the definition of absolute value, negative x looks like a negative number. But that is only the definition when x is negative. So negative x stands for a positive number. For example, when x equals 830, okay, when x is positive, 830 is positive, and you put 830 in for x, so what's the absolute value of 830? Well, it equals 830. When x equals a negative 830, the absolute value of a negative 830 is equal to negative 830, which equals a positive 830. And we don't actually look at it like that. We just know when we take the absolute value, you always end up with a positive number. I don't ever write it like that. Okay? So quiz yourself 3. Evaluate each expression. Well, if you look at A, there's some math that we got to do first inside before we can take our absolute value function. You got to kind of treat these like parentheses. So you got to do what's inside first, and then you can take your absolute value. So what's 3 minus 24? You all should be telling me a negative 21. Well, what's the absolute value of a negative 21? It's a positive 21. B. The absolute value of 3 minus the absolute value of 24. Notice how there's nothing inside the absolute value that you need to do mathematics-wise. So this comes out, the absolute value of 3 is 3 minus the absolute value of 24 is 24. Notice how these absolute values, after I take an absolute value, they don't come with me. They're done. We already found it. What's their distance from 0? 3. What's their distance from 0? 24. What's 3 minus 24? 3 minus 24 is a negative 21. So even though these are positive when you take the absolute value, because of this sign right in the middle, I got out a negative number. So let's look at C. The absolute value of a negative 3 is a positive 3 minus absolute value of a negative 24 is a positive 24 minus the absolute value of 18 is 18. 3 minus 24. What's 3 minus 24? Negative 21. It's a negative 21 minus 18. Both signs are the same, so you add them together. Gives me a negative 39. Take your time, follow your steps, get your answer. This is what your homework should look like. When we graph absolute values, okay, if you only put in positive numbers, sometimes your expressions are going to look like they are equivalent. Notice, if I put in 0 for 2x, I get out 0. If I put in 0 for an absolute value of 2x, I also get 0. If I put in 1, I get out 2. If I put in 1, 1 times 2 is 2. The absolute value of 2 is 2. Okay? And then they went ahead and plotted these points. So if you look at this, if you only look at the positive numbers, okay, these things look like they are equivalent. This is what I'm trying to tell you. When dealing with absolute value problems, you have to look at negative values for x. What are negative values for x? Well, negative 100, negative 10, negative 50, negative 25. Okay? Negative values. Put negative values in for x. Notice we just put in positive values. And on the next slide, they're going to put in some negative values for us. Notice, they put in a negative 5, negative 4, negative 3. When x equals a negative 5 for this expression, 2 times a negative 5 is a negative 10. When I put in a negative 5 here, negative 5 times 2 is a negative 10. The absolute value of a negative 10, however, is a positive 10. Okay? So, if I were looking at this graph, this V right here is my expression, the absolute value of 2x. This line right here, this red line, is my 2x expression. So, if somebody were to ask you, are these two expressions equivalent, you would say, not equivalent. Now, we can type those in on our calculators as well. Okay? And we'll do that in just a second. I think we got another slide to go to. That will do another equivalency. The graphing calculator or computer symbol for absolute value of a number x is absolute of x. In lesson 1-5, you use technology to compare expressions. Now we use technology to compare the absolute value of x plus 4 and the absolute value of x plus 4. So we want to see if those two things are equivalent or not. Now, I want you to be careful. Okay? I'm going to type this into my y1. I'm going to type this one into my y2. How you type that into your y1 is you're going to type in, for this one, abs, and then it's going to give you a parenthesis, and then you're going to say x plus 4. Now, the reason why x plus 4 is all the way in the parentheses is because the absolute value is all the way in the parentheses, or in the absolute value. X plus 4 is in the absolute value. Now, for y2, it's different. Why is it different? Well, only the x is in my absolute value. So when I press abs, I'm going to press abs x, close my parenthesis, and then I'm going to type in plus 4. Okay? And I'm going to show you right now on the calculator how I'm going to do that. Okay. So here we are. I'm going to press y equals. And absolute value is found under your math, arrow over to number. So you're going to press math, arrow over to number, just like that, and press the number 1. So remember, for the first one, I said you are going to put the x plus 4 in parentheses. Now, I didn't realize on my calculator, but it gives me the absolute value symbols. On your TI-83, they actually use parentheses, so that's what I was referring to. Mr. Johnson's not crazy. Okay? So you're going to type in x plus 4. And remember, we wanted those inside there, so that's fine. To get outside the absolute value, all you do is press your arrow key. Okay? So that one's taken care of. My next one, I press math again. Arrow over to number. Okay? I press the number 1 because I want the absolute value. And I only want x in there, so I'm just going to press x. Then I got to arrow out. And then I'm going to type in plus 4. So it should definitely look like what we have right up here. And it does. So now I'm going to hit graph. Or as many as you do, you guys look at it right down here, right? Okay. And if I look at graph, it graphs my first one first, my second one second. So here's my first one. Here's my second one. Now, there's certain parts when these are the same, right here. From 0 all the way to infinity, it looks like. These expressions are the same. But when there's negative numbers, right over in here, these expressions are not the same. They have different values, only from 0 to infinity. So that's why you need to check your negative numbers to make sure that these aren't equivalent. So if you look right here, I got negative numbers right here, negative 19, negative 16, negative 13. And as you notice, your y1s and y2s are not the same. So these two expressions are not equivalent. Okay? Let's look at quiz yourself 4. Test whether the absolute value of x squared minus 6 and the negative quantity x squared minus 6 are equivalent. So let's get our calculator out again. And I'm going to press y equals. And I'm just going to clear these out so I can start fresh. But I'm going to press math, arrow over the number, absolute value, and I'm going to type in x squared minus 6. Okay, it's all in the absolute value symbol. Arrow out. And then I'm going to type in a negative. Remember your negatives down here. Parenthesis, x squared minus 6. Okay. They look the same. Always got to check that sometimes. Don't be lazy. I'm going to hit graph. When I hit graph, I see the first one. I see the second one. If you notice, this one made a W, kinda, shape. And then this one just made a parabola. So from here to here, those functions are the same. But from here out and from here out, those functions are not the same. Therefore, those expressions are not equivalent. Graphs are different. That's all I have for you today. Please enjoy. We'll see you tomorrow.